Hi everyone. Now, like you've probably worked with people that you hate. I've done this, you've done this. We've all worked with people that we hate. Whether they're someone who will microwave fish in the break room, whether they're someone who will take over a social media company, fill it full of white supremacy and lay off half the staff, we've all worked with people that we hate. It's just part of the working life. Now, I want you to imagine this. You're in charge of a team that builds a ticketing system. And someone has come to you and said, you need to build an API. And this person who needs the API is the person that you hate. So you have to build an API for someone that you hate. Now, you could be nice. You could build a good API for these people, but you hate them. So why don't you just be mean and build them a terrible API? And that's what we're going to look at today. Today, we are going to look at 6 steps to build a terrible API for people that you hate. Oh, yes. And on this journey, maybe we might learn a few things we can do for people that we like, possibly. So let's kick it off. Step number 1. The best API docs are screenshots embedded in an Excel spreadsheet. Oh, yes. This is the best way to document your API. Create some screenshots of your API spec, embed those screenshots in an Excel spreadsheet, and send that to the team. And obviously, they have to be wrong. Yes. Now, I've actually seen this in the wild. In fact, this is one of many examples that I'm going to talk about today that I have seen in the global financial industry. Yes, very scary. You take your API docs, you put them in, you put them in some kind of document, you take a screenshot of that, and you embed that in Excel. Yes, that happens. I mean, even now, for example, I used to work for Microsoft. When they send me financial statements for the shares I got in the UK for tax forms, they will embed screenshots in an Excel spreadsheet and send that to me. And that's the best way to do API docs. And in fact, this happens a lot in the banking world. Usually it's things like Word documents or it's screenshots in Excel spreadsheets. Now, the problem with the global banking environment, which I used to work, where you see this a lot, is on one side of the fence, you have developers who know nothing about the business. On the other side, you have business people who know nothing about development. And so in the middle, you have what's called business analysts who know nothing about development and nothing about the business. And they are the ones who normally spread these API docs around. And they will do it in screenshots. And of course, because it's a screenshot, it gets out of date. Same as if it's a Word document. It gets out of date. It doesn't match what you have in the real world. And that's a great thing to do for someone that you hate. Now, if I was nice, Jim, if I was building an API for someone I didn't hate, what I would actually do for my API docs is I would provide an open API spec. This is an industry standard way that you can use to generate good documentation and client SDKs. Open API specs define in either JSON or YAML what your API looks like. You can define your endpoints, the requests that you're going to send, the responses that you get back. It's defining essentially code. From that, you can feed that to a documentation generator. You can feed it to a client SDK generator. And in the JSON that you create, you can put things like examples. You can put detailed documentation. So nice Jim would use Open API, not screenshots in Excel. Okay, thing number 2 we're going to do, get all the things. Yes. For example, if you want to create a new user in our ticket system, what we would do is we would get a new user, obviously. Now, you probably noticed get here is in capitals. So what am I referring to when I have get in capitals? It's obviously, it's a thing. And what I mean by get here is I'm talking about HTTP request methods, also known as verbs. So when you make a web request, when you call a REST API, you have to provide the method that you're trying to call. Get, post, put, patch, and delete are kind of 5 of the most popular. So for example, get means give me something. When you go to google.com, you're making a get request to Google for a web page and it returns you the raw HTML. So a get is designed for making a get request, as in I want to get something from you, give me something. Post, put, patch, and delete match with CRUD, create, replace, update, delete. These HTTP request verbs very much based off the kind of database model where you create objects, replace them, update, or delete. Post means create an object, Put means update an object. Patch means update certain fields of an object. Delete means delete an object. And these are all industry standards. So everyone should know that if I want to get an object, like a user or a ticket, I make a get request. If I want to create a user, I'll make a post request. This is standard. So of course, as we're doing this API for people we hate, we're not going to bother with this. We're going to use gets for absolutely everything. Get with a body, that's how we're going to create a user. Now, would Nice Jim do this? Nice Jim would not do this. Nice Jim would actually support request methods correctly. So use post to create a user, put to update a user, delete to delete a user, and get to get a user. This helps new developers on the API actually understand it because these are standards. Okay, number 3. Naming things is hard, so let's not bother doing it well. It's the 4 hardest things in computer science. 4 hardest things. Naming things, cache invalidation, and off by 1 errors. 4 hardest things in computer science. So when we think about our API, let's not name it very well. Let's just create a load of endpoints and give them whatever name that we want. It doesn't matter. It could be terrible naming. So for example, we can have add_ticket to add a ticket. We can have uTicket to update a ticket. Because why put the whole word update? It's too long. All tickets in camel case to get all tickets. And then to get one ticket, we can have /ticket. And we can spell it wrong. It doesn't matter. Once it's in our API docs, it's too late. We've told people how it works. People are using it. We can't change it. It doesn't matter if we spell it wrong. Obviously, we'll spell it right in our API docs, but we'll spell it wrong on our API. Lots and lots of endpoints. So it makes no sense to anyone using this how to interact with the API. Now, would Nice Jim do this? No. Nice Jim, what Nice Jim would do is Nice Jim would actually think about those request methods we just spoke about and support those correctly. And that way we can have just one endpoint. We can have /ticket or /ticket with an ID. And that way, if we want to get a ticket, we can get a ticket. If you want to add a ticket, we can post a ticket. If you want to delete a ticket, we can send a delete request ticket. By using those request methods correctly and having a single name for our ticket endpoint, we have something that makes sense to any user who wants to do this. That is what Nice Jim would do, but we're not nice. Okay, step 4, request bodies. Yeah, let's just use those. Let's not bother with path parameters, query parameters. Let's just use request bodies for everything. So what do I mean by this? If I want to get a ticket, I make a request to /ticket, spelled wrong, obviously, and I pass the ticket ID in the body. Pass ticket underscore ID of 1 in the body, and that way I can get that single ticket. If I want to update a ticket, I'm making a request to /uTicket, get request, obviously, and then in the body I can pass the ticket ID, and then a list of all the fields that we want to update. Nice, simple. If I want to search for a ticket, I can maybe add a search tickets endpoint, and I can pass the search criteria in the body. Easy. This is obvious. This is what everyone does, right? Yeah. Now, if I was Nice Jim, I wouldn't do this at all because this is not standard. This is not what people do. Nice Jim would use path parameters and query parameters instead of putting identifiers in the request body. So what I mean by this is if I want ticket 14, I don't call /ticket and put a ticket ID of 14 in the body. I would call /ticket /14, /ticket /15, so on. That is what we're used to doing. That's the standard way of accessing resources. Make a get, put the resource ID in the get. Same with things like queries. The standard way is to make a get and pass query parameters. At the end of my URL, key equals value, key equals value, key equals value. That is standard. Anyone new coming to my API would know how to do this. They can look up what the query values are, add those query parameters. They would know to get a ticket by ID, they could put the ID in. They'd know if they want to get a field on a ticket by ID, it's /ticket /ID /the field name. Things like that. These are all standards. So Nice Jim would use path parameters and query parameters correctly. Step 5, non-200 status codes. These are bad. These make your client code throw exceptions. We should never return anything that's not 200. Always, always, always return 200. Yes. You may have seen this. You make a call to an API, it returns 404, your code throws an exception. We don't want that. This team, we hate them. That if their code throws exceptions, they might blame you. I don't want to take the blame because your code's throwing exceptions. No, so I'll just make sure my API always returns 200. Exceptions, not my problem. So what do I mean by return a 200? Well, return a 200 means okay, so we can return a 200 and we can put the error message inside the body if there is an error. 200 okay, body says status 404, ticket not found. Things like that. That's what I mean by return a 200. Always return a 200. If there's an error, we put that in the body. Yes, job done, no exceptions. Now, what is these 200, these 404, these status codes? Now, they actually mean something. So there is actually value in the number that we are returning. Anything in the 100s means hold, please. Your request is not able to be completed, but waiting on something. Anything in the 200s means, here you go. Okay, created, it worked. Here's your return value, whatever. 200 means it worked. The 300s mean go away. Redirect to somewhere else, endpoint not available. Something like that. You need to call something different. 400s means you mucked up. You've sent me bad data. You're accessing a resource that doesn't exist. 500 means I mucked up. Server error. I broke something my side. So these status codes actually mean something. They have value. Some classic examples. 200, okay, it worked. You did a call, here's the results, 200, okay. 400 means a bad request. You sent me something wrong. You're trying to update the field or an object and that field doesn't exist. Things like that. You've sent me something wrong. 401 is unauthorized. You don't have rights to do this. You need to log in, or you need to log in with a user who's got different rights. 404 not found, standard one. You're asking for a resource that doesn't exist. /ticket /2000 when we've only got 1,000 tickets. Doesn't exist. And 418, I'm a teapot. It's a thing. Look it up. If you're a teapot, always return a 418. But we don't care. We're always going to return the 200. That way the client code doesn't crash, and that way our users have to read the response body. Yeah. Yes. Now, if I was nice, Jim, I wouldn't do this. If I was nice, Jim, I would actually return the appropriate status codes for the error. And then I'd include more details in some kind of response body. Not found, return a 404. Server error, return a 500. And then in my OpenAPI spec, how I define my documentation, I would say that my endpoint can either return 200 okay, or it can return a 404 or a 500. And then this is the structure of the response that comes back, the error message. It could be like an error message, could be more details, could be status, whatever. I would define that response that comes back. That's what nice Jim would do. Or return the right status code. That way I can handle that correctly. There are certain 500s that I want to do a retry. Server busy, do a retry. I could build that code in just by monitoring for the particular return code. So the nice Jim would use the right status codes. Finally, number 6, atomic updates. Nah, we don't need atomic updates. Our API does not need atomic updates. No. So what do I mean by that? Imagine we're creating a user. And in our database, we have 2 tables, user and user details. We receive a request, got a lot of fields in it. We start by pulling out the fields we need for the user table, maybe like an email, create a unique ID, and we'll insert that record in the user table. User exists, done. Then we'll go back to the rest of the request, pull back the rest of the fields we need, and set those in a user details table. Only we didn't bother to validate because, whatever. And we're actually missing a line from user details. So we can't create the user details table. Error, fail, return a 200 with a request body saying, you didn't send me this field that I need. Sounds okay so far. Except when they try again. Because we've already put the record into the user table, there's a duplicate. So we can't create the record in the user details table. Our API throws an error. And so we end up in the situation where you call it once with missing data, and you can never call it again to create the user. Now, this is great, especially in the banking industry where contractors get paid by the day. Because what happens in this situation is you need to run a database update script. And they usually run at weekends. And so a DBA has to come in at the weekend to create a break glass account so that the engineer can run a SQL script to delete the entry from the user table, and you can update it. 2 people build for an entire day for a few minutes work on a Saturday. Thank you very much. Lots of cash. That's the best way to do it, right? Well, NiceGym wouldn't do this. NiceGym would ensure that all updates are atomic. So if the API call fails, the system remains in the same state as before the call. So that way, it doesn't matter what I call, if it fails, the system never changes. And ideally, we should go further so that every time I call things don't change unless they have to. Calls can be reproducible. I can call the same thing and get sensible errors. That's what NiceGym would do. Any updates are atomic, either make all changes or no changes. That's what NiceGym would do. So we looked at ways we can build a terrible API for people we hate, but really, what if we don't hate them? Because let's be honest, with a few exceptions, contact me on social media to find out maybe some more details of those exceptions. I'm not going to tell you about them now. With a few exceptions, I don't hate people. In general, I want to build a great API for the people that I work with. And so 6 good tips to build a great API. Number 1, provide an open API spec. Make sure it's right, it's detailed, it's got descriptions, it's got examples. From here, you can build great documentation or great client SDKs. Use the correct request methods. Get things, post to post things. Yes, there's discussion around generative endpoints. What happens if you need to have lots and lots of key value pairs in your query string? The rules are not hard and fast. They don't work perfectly. So, sometimes you have to bend the rules, but in general, use the correct request methods where you can. That's obvious to somebody using your API that that's how it works. Have good naming. By using request methods, you can have endpoints that are the same name, but do different things depending on what request that you want. If you're accessing a ticket, it should be /ticket. Get to there to get a ticket, post to create a ticket. So use that good naming. And then use things like path parameters. If I want ticket 12, I'm going to /ticket/12, not /ticket with 12 in the body. So use those path parameters. If I'm getting results with a query, use those query strings. Return the proper status codes so we can handle everything correctly. Don't just put 200 with an error body. Always turn the right status code, put the appropriate error into the body when necessary. And then always do atomic updates. When you make an update, it's got to fail and nothing changes, or it's got to work. That's it. With that, thank you very much indeed. I'm Jim Bennett, Principal Developer Advocate at liblab. We build client SDKs for your APIs all over the internet at Jim Bennett. So please get in touch if you've got any questions from today. Thank you.